Happy morning, students. Last section we saw the physical properties of carbon family, that is group 14. So we saw the physical state, atomic number, isotopes of and atomic masses of carbon family. Today we are going to see the electronic configuration of carbon family, carbon 6. A general electronic configuration is NS2 NP2. Now see here, the first 1s2 is helium. So no stable electronic configuration of helium, stable element, that is group 18. The remaining is this outermost electron, 2s2 2p2. Only the outermost shell will vary. Now see, the silicon is 14. Neon atomic number is 10. The remaining 2 plus 2 is 14. 14 is this atomic number of silicon is 14. Germanium 32. So argon 18. Outermost 3d10. This is 4s2 4p2. Tin 50. The outermost is krypton 4d10 5s2 5p2. Lead 82. Xenon 4f14 5d10 6s2 6p2. Now see here, there is 2s2 2p2, there is 2s2 2p, 3s2 3p2, 4s2 4p2, 5s2 5p2, 6s2 6p2. Now next is atomic radius. Atomic increases from carbon to tin, decrease from tin to lead. Density decrease from carbon to silicon and increase from silicon to lead. Melting point, boiling point. The carbon sublimate at 4098 Kelvin. Now decreases melting point, and melting point of decreases from silicon to tin, and boiling point is increasing from tin to lead. Okay, now the next is tendency for catenation. You already learned the catenation in organic chemistry. Okay, now same thing we are going to see here. Catenation is the ability of element to form a chain of atom. So carbon 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 linked. Okay, the condition for catenations are the valency of element is greater than or equal to 2. So the valency of the element is greater than or equal to 2. Element should have ability to bond with itself. They have the ability to form a bond with itself. The self bond, this is self bond, must be strong as a bond with other element. A gynic inertness, they are not taking part anything. Okay, catenate compound towards the other molecules. Carbon, these are these 4 points are condition for the catenation. Carbon possesses all the above properties. So carbon will satisfy all these 4 properties and show the catenation. Carbon form a wide range of compound with itself with other element such as hydrogen, carbon bond with hydrogen, oxygen, nitrogen, sulfur and halogen. So there is a tendency for catenation. Now see the allotropies of carbon. Carbon allotropies, we already, what are they? Graphite, diamond, fullerene, graphene, carbon nanotube. First, see the allotropes of carbon exist in many allotropic forms. Graphite and diamond are most common allotropies. Graphene, fullerenes and carbon nanotube are other important allotropies of carbon. Now first we'll see the graphite. Let's see the structure of graphite here. This is the structure of graphite. Okay. It is the most stable allotropic form of carbon at normal temperature and pressure. It is soft and conduct the electricity. It is composed of flat two-dimensional sheet of the carbon atom. It is a flat two-dimensional sheet of the carbon atom. Each sheet is hexagonal, like hexagonal net of sp2 hybridized carbon atom with CC carbon bond with carbon bond CC bond. CC bond length is 1.41 angstroms. which is close to carbon-carbon bond distant in benzene. Benzene is 1.40 angstroms. So we see it's a more stable allotropic form of carbon. It is a soft and conduct the electricity. It is composed of flat two-dimensional sheet of carbon atom. Each sheet is an hexagonal net of sp2 iodized carbon atom with CC bond length is 1.41. In the case of benzene, CC bond is 1.40 angstrom. Each carbon atom form a 3 sigma bond. 3 sigma bond. That means you see here the carbon will have a 3 sigma bond. The valence of carbon is 4. So 1, 2, 3. Remaining 1 electron is there. This is a free electron. Each carbon atom form a 3 sigma bond with neighboring another carbon with neighboring carbon atom using the 3 of its valence electron, and 4th electrons are present in unhybridized p orbital. Unhybridized p orbital form a pi bond. These pi bond are delocalized over the entire sheet. Entire sheet means all the sheet, all the carbon have a free electron is there, okay, which is responsible for the electrical conductivity. The free electron will conduct the electricity. The successive free electron, each carbon bonded with other carbon atom. The free electron is a delocalized. The pi electrons are delocalized over the entire sheet, which is responsible for electrical conductivity. The successive carbon sheet 1, sheet 2 are held together by the weak van der Waals force. Here is sheet, another sheet, 1, 2, 3 more sheet is there. So the bonds are held together by these are the van der Waals force. The distance between the successive sheet is 3.4 angstroms. It is used as a lubricant either on its own or under graphite oil. So up to graphite, this one is graphite. These are the properties, some of the important points in the graphite. Next we'll see the diamond. Carbon atom in diamonds or sp3 hybridized. That is, graphite is sp2 hybridized. Each, because all the 4 bonds are single bonds are used here. There are only 3 bonds. One is free electron in graphite. Each carbon is bonded tetrahedrally with 4 other compound by single bond with CC bond length is 1.4 angstrom. Hence the diamond is hard. All the 4 valence electron of carbons are involved in bonding. All are involving in bond, and there is no free electron in diamond. So it is a non-conductor of electricity. Being a hardest substance, diamond is used for sharpening the hard tools. We are going to sharpen the hard tools, cutting glasses, making bows, and rock drilling. Then next is the Fullerenes. These are newly synthesized allotropes of carbon. Unlike graphite, diamond, these allotropes are discrete molecule. We can find out each carbon atom here, such as carbon 32, carbon 50, carbon 60, carbon 70, carbon 76, etc. These are cage-like structure. So you didn't see the diamond structure here. The structure of diamond. Then next is Fullerenes. Okay, this is so the discrete molecules, that is carbon 32, carbon 50, carbon 60, carbon 70, carbon 76, etc. It's a cage like a ball, like a structure. Next, the C16 molecules have a so is a ball. That means you know the ball, basketball will have that same structure. Like the structure, it is called Buckminster Fullerene or buckyballs. It has a fused ring structure, consists of 26 membered ring and 12 5-membered rings. Okay, what are these of buckyball? It has a 26 membered rings and 12 5-membered rings. Each carbon atom is sp2 hybridized and form a 3 sigma bond, and delocalized pi bond is giving a aromatic structure. So the whole structure we can see the aromatic structure, because 5 membered also aromatic, 6 membered also aromatic. CC bond, carbon carbon bond distance 1.44 angstrom. Carbon carbon double bond distance is 1.38 angstroms. Tomorrow we'll see the next carbon nanotubes and graphene. Thank you, students.